So the other day we made a video about the heat death of the universe, which got me thinking about the beginning of the universe. And since I can't resist making videos where I talk about myself in the third person, here is how our current theories say that the universe began. Current scientific theories say that the universe began around 13.8 billion years ago with the Big Bang. Just before this, space was infinitely small and infinitely dense, containing all of the matter and energy that would eventually make up everything that we know today. But don't be too surprised if that sounds kind of confusing, because it's true that science doesn't really know how the universe began. In fact, our theories break down at the very beginning. They just have some good guesses. Well, turns out that the particles were mostly photons, the particle of light, and the rest were mostly protons and neutrons, which combined to form atomic nuclei. These particles couldn't form atoms yet because they weren't cool enough. I mean, they're now, right? You just need to get down to like a few degrees above absolute zero. And then you can just wait for the protons to find some electrons to combine with. This isn't something that scientists expected to find, and it was very hard to measure at the time. His theories of special and general relativity describe how space and time work, and they rely on the idea that the speed of light in a vacuum is constant. When you shine a flashlight in a room, the light reaches the far wall at the same time no matter where you move. That's because the size of the room is constant. But if you kept track of the distance between you and the wall as the room expanded, it would seem like the light was taking longer to reach the wall even though the speed of light didn't change. If you wanted to change the speed of light, you would have to change the laws of physics. And those interactions leave behind a tiny bit of energy in space itself. It's kind of like if someone threw a baseball straight up in the air, then caught it. You wouldn't be able to tell that the baseball was ever thrown. But if it hit a wall, you would notice that the wall vibrates a little bit afterwards. Those vibrations are the analog of the temperature of space, and they come from the interactions between virtual particles. The problem is that the temperature of the black hole would have to be extremely hot, like billions of degrees. In any case, the point is that we know that the universe began with a high concentration of matter. But we don't know why or how. And we know that the early universe wasn't that hot. We have some good guesses. The most popular one is called inflation, and it says that there was a period of extremely rapid expansion of the universe, like 10 to the 26 times faster than the expansion of the universe is now. This would have smoothed out a lot of the matter distribution and explained why galaxies formed the way that they did. We also don't know why the expansion of the universe seems to be speeding up. So click here to watch this video about dark matter, or click here to watch this video about the heat death of the universe. Don't forget to subscribe, and thanks for watching. It's a hypothetical particle that scientists believe played a crucial role in the evolution of the universe, especially during the first fraction of a second after the Big Bang. And the last problem is that it doesn't really explain why the universe began the way that it did. It just pushes the question back another step. Scientists are working on some new experiments to try to detect Hawking radiation, which could tell us whether or not we live on the surface of a black hole. And there are some experiments looking for evidence of inflation, like the BICEP collaboration. So while it's a good guess, it's not a great theory. But it's not predicted by any theory, and it's not been observed. Some places will have a higher temperature than others, and those variations will cause matter to clump together, which eventually forms galaxies. Maybe we live in a black hole, or maybe we live in an inflationary universe. Or maybe we live in a simulation. The point is that we don't know how the universe began, but that doesn't mean that we won't find out. It's a really elegant solution, but it requires us to assume that the universe began with quantum fluctuations, which means that it would have begun with a random distribution of matter, which doesn't seem to fit with observations. And bending of light tells us that there was matter there previously. So we know that there was matter throughout space. That means that the quantum fluctuations may have not been random, but instead caused by some unknown mechanism. Otherwise, stars would be evenly distributed throughout space. Space would have been mostly empty, and then some random fluctuations would have caused some pockets of high density that eventually formed galaxies. But we know that this wasn't the case because there were lots of interactions happening in the early universe. We know that quantum mechanics is weird, and one of the ways that it's just weird is that particles can be in multiple places at once. We can use this property of quantum mechanics to explain how empty space has a temperature. One of my favorites is that our universe is a black hole and the stuff on the outside is inside of the black hole. That means that the inside of the black hole has a surface and we live on that surface. And the reason that we can't fall off of it is that there's nothing below us. It's all imaginary. I mean, technically, infinity is below us. But you get the point. Because we know that empty space has virtual particles that pop in and out of existence all the time. Instead, we see that stars form in groups and clusters, which suggests that there was some variation in the distribution of matter at the beginning. Otherwise, they would all be evenly distributed, which they aren't. But we do know that we can't change the speed of light unless we change the laws of physics. So that means that space must be expanding everywhere at once, not just next to other places that are moving away from each other. So his theories of special and general relativity don't say anything about how the universe began, but they do help us understand how space and time work. After a few 100,000 years, the universe cooled enough for the protons and neutrons to combine into atomic nuclei. Then after another few 100,000 years, the electrons combined with those nuclei to make atoms. At least that's how we think it went. But once they realized that the entire universe had a temperature now, you might think that the creation of elements inside of stars refutes the Big Bang, and that's true. Of some versions of the Big Bang, but most versions don't actually include how elements are made. They just describe the expansion of the universe. So the Big Bang isn't really a theory about stellar evolution. It's just saying that at some point, everything was really close together and then started moving apart. We can see this in the oldest stars that we've looked at because their composition matches that primordial soup, mostly hydrogen and helium with a little bit of lithium. In fact, we can even tell how old those stars are because as the universe gets older, different elements become more possible. It made sense because it meant that all of the light waves coming from different parts of the sky should be redshifted by the same amount which they were. And then stars began to form, and that caused even heavier elements to form inside of them. All of the stuff that were made of iron, nickel, oxygen, all came from the insides of stars. And all of that stuff was spread throughout the universe when those stars exploded. This also explained why everything was moving away from everything else, because if the universe has a temperature, it means that it's full of particles and those particles are moving. It's almost like how no one knows exactly how life on Earth began, but we have a pretty good idea based on what we know about biology. The name comes from the fact that the universe was expanding. So everything was moving away from everything else really fast, and we call that the Big Bang. There was also a lot of radiation flying around. We think that DNA self-replicated until it became more stable and then natural selection took over. We might never know for sure, but we have evidence for our hypothesis and it makes sense given what we know about the world. And it's the same thing with the Big Bang. It's not a theory in the sense that it's a guess. It's a theory in the sense that it's our best explanation for a wide range of observations that we can test. But let's try to take a look at what we think happened anyway. So the Big Bang wasn't actually an explosion in the traditional sense. We know this because in the 1960s they discovered that space had a temperature of about 2.7 Kelvin or about 270 Celsius. But wait, if the universe was full of particles, shouldn't there be stars and planets and stuff already? So back then, the universe was filled with this primordial soup of particles moving around. We have some evidence for this because as the universe cooled, different elements became possible. First, hydrogen and helium, and then lithium. After a few million years, beryllium was able to form, and then boron and carbon. That's how we ended up with a nice mix of all of the elements that we remade of. It's also consistent with Einstein's theories of special and general relativity. And importantly, they help us understand that the only way for the speed of light to remain constant is if space expands. What I'm getting at is that we don't know how space could have begun to expand without having a cause. We also know that space wasn't always the way that it is now because it's hard to imagine how galaxies would form. This variation may have come from quantum fluctuations. We also know that these virtual particles have a very short lifespan, but during their very short lives, they can interact with each other. Since the particles that we're talking about are virtual, we don't know exactly how strong their interactions were, but we do know that there will be some variation. If the distribution was random, you would expect the early universe to be mostly empty. We know this because we can see how light bends around massive objects. The other possibility is that the matter distribution wasn't random, but came from some unknown physical process. Okay, in all seriousness, the reason that this is a bad theory is that we know that the inside of a black hole has a temperature and it's just called Hawking radiation. Also, there are other problems with black hole thermodynamics, but I don't want to get into that. We also don't know exactly what happened next. There are some problems with inflation, though. For one thing, it requires a particle called the inflaton. Another problem is that it's hard to reconcile with Einstein's theories of special and general relativity. In the end, we don't really know how the universe began, but we're trying to figure it out. You can read about them yourself and decide for yourself what you think the evidence says. In the meantime, we have plenty of other videos to watch.